Hey, what's up, everyone? I'm gonna do this one page for this week's notes. Sorry it's so late. Yeah, I guess I'm like you guys. It's this is really tough to kind of get on a schedule to do things. So I apologize. Got family stuff, and I really apologize. So next week I should be on more of a better schedule. So here we go. So part one. So this one is for this week's notes, and remember, the quiz will show up tomorrow on Friday. Everything's due on Sunday, but if you need more time, go ahead and take it. Second page will be next week, so it's just a continuation of this. So let's talk about angles and radian measures. So basically, we're going to do two things here. We're going to look at angles. You guys know what angles are, but we're going to measure them a different way. We're not going to use degrees, and we're going to put angles on the coordinate plane instead of just looking at them floating in the middle of space. So if you look here, angles in standard form. So we're going to have an angle, and we're going to put it on the XY axis, okay? And I know it's a little weird, but we're going to put it on the XY axis, and we're going to measure angles from here. So we're going to have, remember, there's two sides of an angle. There's one side called the initial side. That's the one that doesn't move. And then there's one that moves, the other side of the angle, called the terminal side. So if you look here at this picture, this first part of the angle in purple is the initial side of the angle we're going to look at. Okay, so that's the initial side. This doesn't move, it stays where it's at. The other side of the angle that you see here with the arrow that I'm drawing in red, that's called the terminal side. And they call it the terminal side is because that's where the angle ends. It starts at the initial side. You know, initial means beginning. And then it terminates at the terminal side. So you see that arrow shows you how the angle is formed. So this angle right here is formed. Initial side stays still. Terminal side kind of swings. If you notice, it swings counterclockwise. So if we look here, we can look at our notes. An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis, right? This side right here, this purple side, is on the positive x-axis. So the ray on the x-axis, we just said, is called the initial side. The other ray is called the terminal side. And counterclockwise rotation. So if we look here, you see the way this arrow right here, the direction it's going in a counterclockwise direction. So the terminal side is moving that way. That's how the angle is formed. They both start at the initial side, and then the terminal side kind of swoops over counterclockwise. And a counterclockwise rotation results in positive angle measures. So now we can have angles that are positive or negative. Okay, so if it goes counterclockwise, it's positive. If it goes clockwise, so like if I was starting at the initial side and I went down this way, that would be a negative angle. But we're going to deal with positives for the most part. So clockwise rotations result in negative angle measures. Okay, and if if you're a skater or if you've seen sports where people spin and stuff, what would a full rotation all the way around be measured? It'd be 360 degrees, right? A 360. Okay, so if you look here, we can divide the quadrants into angles. So if the entire thing is 360, that means if I go 1/4 of the way from here to here, that's 90 degrees. If I go halfway from here to here, that's 180 degrees. If I go 3/4 all the way and I stop here, that's 270 degrees. And if I go all the way around, it's 360 degrees. And it keeps spinning and spinning and spinning. I can actually keep going. If I do 2 full revolutions, that would be 720 degrees. So it's kind of infinite. I can keep going and going and going. And when we start doing graphs of these, you'll see how cyclical it is, how it keeps going back and forth, up and down, because we can go on forever. So let's draw some angles. Let's practice this and let's draw some angles. So we're going to sketch an angle for 1, 2, and 3 of what it says. So 75 degrees. So again, here's my initial side. That's going to stay there. That's one side of my angle. Where's the other side going to be? Well, we know all the way around is 360 degrees. Halfway around is 180 degrees. A quarter of the way around is 90 degrees. So if I want to go 75, I'm going to go very close to 90. So I'm going to swing up this way to about right there. And that'll be 75 degrees. Okay. Now, number 2 says I want to do a negative angle. So again, I'm going to start here on the x-axis. That's my initial side. And the other one's going to swing down. So now we got to kind of count down. So if I went from here to here, that would be negative 90 degrees. If I went from here all the way to here, that would be negative 180 degrees. But I want to go negative 160, so I want to go almost to 180, but not quite. And so maybe about right there. And there's my angle, my negative 160 degree angle. Okay. If this is not making sense to you, please send me a question on Remind. Send a question on Remind saying, Mister, what the heck are you talking about? I drew this. Is this close? Just ask me what you need to know. Tell me where you're confused. Okay. Now let's go over here, 430 degrees. So let's draw our initial side. And now 430, you notice that's bigger than 360. So if I go, if I go all the way around, that's 360. So I'm going to have to go all the way around and then some. So let's try that. Let's see that. I'm going to go all the way around, and then I have to go more. Well, how much more do I have to go? So if I have to go 430 and one full revolution is 360, well, what's 430 minus 360? 70? Right? So that means I'm going to have to go a full revolution plus 70 degrees more. And we know up to here is 90 degrees. So I'm probably going to go about right here. And so that angle would look like this. But you see it twisted all the way around once, and then it went another 70 degrees. Okay, later on we're going to look at this and see that it kind of looks like a 70 degree angle too, right? If I drew a 70 degree angle on top of this, it would look exactly the same. It just wouldn't have that loop. So we'll talk about that in next week's notes. They're called coterminal angles, by the way. So this is how we draw angles in standard form on the coordinate plane. Okay, any questions? Well, you can't ask me now because this is a video, but you can stop it here and go on Remind and send me a question saying, hey, mister, what the heck were you talking about? I don't understand this. Be more clear, and I'll help you out. All right, let's move on to radians. Now, do you know why degrees is 360? A long time ago, they I think they were using a circle for a calendar. So there were about 360 days in a year. So they said, hey, let's cut up a circle into 360 equal parts. And that's where the degrees come in. Half of a circle is half of the degrees. So that's where 180 came from. But mathematicians wanted to be a little more mathy, right? And they know that pi, 3.14159 ... is the ratio when you look at circumference and diameter. And so pi, they wanted to make a more mathy way of measuring angles. So they came up with radians. So this is basically what a radian is. A radian is an angle formed. So if you look at the circle, an angle formed when the radius and the length of the arc that it creates are the same. So when this is r, length r, and this arc is length r, when they're the same, that means it's 1 radian. And this little symbol right here, that's theta. Let me write that better. Okay, that's the Greek letter theta. That's all that is. It's just like the letter A, B, C, but you'll see theta a lot in trigonometry. So 1 radian is how we measure angles in trigonometry. We still can use degrees, but we use radians because it deals with pi. And let me show you. So here's the words, the nerdy words, right? A radian is a unit of angle measure based on arc length, like I just told you. When arc length, the length of that arc, is the same as the radius, you have an angle that's 1 radian. Okay, and you don't have 360 radians in a circle. That's not like degrees. It's a little different. So 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Okay, so if you remember that the circumference of a circle was 2r pi, or 2 pi r, then that means 360 degrees would be 2 pi's. Okay, and 180 degrees would be 1 pi. Okay, so now we're looking at pi's, and now here's where some of you are going to moan. We have to look at the measure of angles in terms of pi, where pi is 180 degrees. So if instead of saying an angle is 180 degrees, you would say an angle is pi radians. Now we're going to have to do fractions, the F word. We're bringing that back. We're going to have to do fractions of pi to figure out equivalent angles. And we're going to have to convert between degrees and radians. So let's see how that is. So using that 180 degrees is 1 pi radian, and 360 degrees is 2 pi radians. Okay. Here is the formula to go from degrees to radians. I get my radians, I get my degrees, and I multiply it by pi radians, and I divide by 180. Right? Because I'm dividing by 180 because 180 over 180 is 1. So if I had 180 degrees, what's 180 divided by 180? 1, and that would get me 1 pi radian. Okay? So if I want to do degrees to radians, I would do the opposite. Instead of dividing by 180, I would multiply by 180, and then I would divide by pi, because there's no pi in degrees. Radians have a pi in it usually, degrees don't. Okay, so let me show you what I mean. So let's do a simple one. I'm going to do a simple one here on the side. If I look here, and let's say I have a 90-degree angle. Okay, how many radians is that? Well, if you remember what I told you, from here to here is 1 pi. Right? From here all the way around is 2 pi. 2 pi is 360 degrees. 1 pi is 180 degrees. Well, 90 degrees is half of 180, isn't it? So 90 degrees is half a pi. So we can just say it like that. 90 degrees is pi over 2, or 1/2 pi. Okay, so now let's use the formula to do that. So if I were to use the formula, here's my degrees, right? So I'd get my degrees, which is 90 degrees. I'd multiply it by pi radians, and I divide it by 180. So what's 90 over 180? Well, if I divide by 90, that's 1. Divide by 90, that's 2. I would get pi over 2 radians. And you ever notice on your calculator, it says DEG or D or degrees, and then it says rad, R-A-D, or R, or radians? That's what this is referring to. When we're doing trig, you have to let the calculator know, are you talking about degrees or are you talking about radians? So when we're doing this trig, make sure you have your calculator in the right mode, degrees or radians. Okay, so let's look at the first one. Let's look at number 4, 30 degrees. I want to change that to radians. So here's 30 degrees. Now I'm going to do what? Look at the formula, right? I'm going to multiply by pi and divide by 180. So basically that's 30 over 180 pi. Cancel out the zeros. 3 over 18 is 1 over 6 pi, or if I put them together, because pi is over 1, it would be pi over 6. So 30 degrees is pi over 6 radians. Okay. If you're not understanding it, back up. Look at my explanation again. Here are the formulas. Just plug in your degrees into the formula to get radians. Okay. Let's look at number 5. Again, I have 150 degrees. So 150 degrees. I'm going to multiply by pi and divide by 180. Okay, so that means I put 150 over 180, and then put the pi right next to it. The zeros cancel out. 15 over 18, well, I can divide both of those by 3. So if I divide 15 by 3, that's 5. If I divide 18 by 3, that's 6. So that's 5 6 pi, or 5 pi over 6 radians. Okay, and just remember, degrees is always going to be a bigger number because a full rotation is 360 degrees. Radians is always going to be a smaller number because it goes from 0 all the way to 2 pi. 360 degrees is only 2 pi's. Okay, so now let's look at number 6. We have negative 220 degrees. It works. This formula works with negative degrees. Because you can also have negative radians. So if we put negative 220 degrees and we plug it into the formula, which means we multiply by pi radians over 180 degrees. So we have negative 220 over 180 pi. The zeros cancel out. 22 and 18, I could divide both of them by 2. So that's 11 over 9. So I have negative 11 ninths pi, or negative 11 pi over 9 radians. Okay. So that's how I convert from degrees to radians. Now let's go from radians to degrees. Let's try this. So now I have a fraction, 4/3 pi. So really quick, is this more or less than 1 pi? 4/3. So you got to know your fractions. Remember, I've been telling you got to know your fractions. Well, 3 over 3 would be 1 pi, wouldn't it? This is 4 over 3, meaning I have 4 slices of a 3-slice pie. So I have more than one pizza. So I have more than one whole. So this is more than 1 pi. So it's going to be more than 180 degrees. Remember, because 1 pi equals 180 degrees. Don't forget that. Pi radians equals 180 degrees. So you know it's going to be over 180. So let's put this into the formula. So if you look at the formula, if I want to get degrees, I get my radians. I multiply by 180, multiply by 180, and then divide by pi. Okay, so let's try that. So 4/3 pi. Remember the pi's up here, so 4 pi over 3 times, I'm going to multiply by 180, so 180 is in the top, and divide by pi. And the pi's cancel out. And if I get 180 divided by 3, that's 60. So that's 4 times 60, which is 240 degrees. Okay. Again, let's try the next one. So we have, now we have a negative radian, so that's fine. So we have negative 5 pi over 36. What's the formula? The formula says to multiply by 180 and divide by pi. The pi's cancel out, and so I can just multiply. 180 times 5 and then divide it by 36. So if I do that, if I multiply 180 times 5, don't have a calculator with me, so let me do it by hand. So 180 times 5, oops, 180 times 5 is 0, 40 is 900, and if I have 900, so that equals negative 900 over 36 pi. Does 900 divide evenly by 36? I don't think so. 936. 36 times 3 is 18. That's too much. 36 times 2 is 72. So 72 is 18, 180. So 36 times 5 is 180. Oh, okay. So 25. So this would be negative, and there's no pi. Sorry, I put a pi there. There's no pi. Negative 25 degrees. The pi is canceled out. There's no pi there. So negative 25 degrees. So all I did was I multiplied negative 5 times 180 in the numerator. I got negative 900. 36 times 1 in the denominator, 36. Divided 900 by 36. And don't forget the numerator's negative. I got negative 25 degrees. All right, calculator does all the work. I didn't have a calculator. It took me a little longer, but that's fine. Just punch into your calculator. You'll get the answer. So let's try 7/4 pi. Again, let's plug it into the formula. Multiply by 180, divide by pi. Okay, the pi's cancel out. I get 180 times 7 divided by 4. So 180, again, 180 times 7 is 1260 divided by 4. And let's see, 4 goes into 12 3 times. 4 goes into 6 1 time with a remainder of 2. And then 4 goes into 25 times. So that's 315 degrees. All right, guys, so that's it for this packet for this week. What we learned how to draw angles in standard form on the coordinate plane, initial side, terminal side. We talked about drawing angles on the coordinate plane. We talked about what a radian is. It's a way to measure angles other than degrees. And 1 pi radian is 180 degrees. 2 pi is 360. It's a full revolution. And then we use that to make these conversion formulas. And then we use these conversion formulas to change from degrees to radians or radians to degrees. I've sent you the answers and the work to this. If you have any questions, please send them to me on Remind. You will have a quiz up on Schoology tomorrow. You have until Sunday to take it. I may give you a little extra time to take it because I did give you this video late. But please send questions if you have any. Okay? All right, guys. See you next time.